This session is going to be on inventory, and probably one of the most important aspects for any client, what they own, to be able to manage it. And so we're going to go through the process of how we collect the information for the owners. Okay. So in this agenda, we're going to go through the process, inventory questions, available data, what is out there that's readily available, inventory organization, data management, data collection, some of the data dictionaries, I will go over, and inventory action. So the first part I will cover. Okay, so this is the reason why we do the inventory, because I just went to one of the clients yesterday, and they had absolutely no idea what they owned. And this was a brand new board that they've been there for 4 years, and even as we went through what we did for inventory, all the staff had been there for years, weren't aware of what their system did, where it was, and everything. So we also went through and we identified the location, and we'll talk about different ways of how you can start putting that information in. But a lot of times, if you start off with your design, you have all your locations in there. So, but you may not have the attributes that are needed. Okay, and then part of the inventory that you're collecting is the information about when it was installed, so that you can start calculating life cycle costs and everything else. So again, finding out what your assets are, doing that initial inventory is important. And if you don't know what you own, you can't do maintenance on it. So a lot of times, towns will have a computerized maintenance, and they'll have it for their vertical assets, for their facilities, and know how they're maintaining them. But the horizontal is response, boom, you got a complaint, and go out there and take care of it. So really, once you set up an inventory of what you own, setting up a good maintenance program is based off that inventory again. And then establishing replacement schedule. So I'm going to read the slide. Sorry. Okay. So what assets do you have? When you're out there collecting information, every asset is different. So how do you collect it, what information you have, and everything else. A hydrant has different information than a pipe has, or a valve. So you have different inventory information. And then where they're located. How do you capture the information? How do you collect it? Right now, the airports have all these attributes that need to be collected for each asset that they have out there, and they standardize it. Most of the time that when you're out there with a client, they don't have a standard list of what they want you to collect. For a pump, it's going to be different than the drive. So knowing what your different assets are, different asset types, is important on what you're collecting. And you have to do that organization ahead of time before you go out and start collecting information. And what do you want to include? Right now, I know that Greg is working and collecting information through an iPad. He's the intern working for the bridge department. And the data that they're collecting, they're also collecting some of the condition of the assets. And typically in an asset management program, you only collect information that doesn't change. So, the pipe diameter doesn't change, but the condition of the pipe does. Now, through his inventory, he's actually collecting condition. The only time you do that is that if you don't have a database that's going to go in and start doing work orders based off that data, condition assessment and risk assessment. Because if that's the information you're going to be working on, it's just your inventory, then you may want to collect additional information. And again, you need to know what your client needs and what to include and how you're going to compile the data, because it's really how is the client going to use the information after you collect it. You know, we just did a proposal for air. One of the first things they asked for was a unique identifier. And, you know, when you go through and you're going to set up your inventory, one of the systems that you need to talk to your client about, what are they going to use for unique identifiers? It's going to be a smart ID. And a smart ID is a number that provides information in it. So for manholes, for Hampton, every manhole number has a pump station identifier in it. So you look at a manhole and you know which pump station that goes to. So if there was a spill of gasoline or anything like that, you'll know which pump station to shut off to prevent it from going further down the system. For storm drains, it may be linked to where the outfall is. So that if you have a manhole number or a catch basin number, it may have in the identification unique number where the outfall is. So these are some of the things that you need to think about in regards to setting up a unique identifier for the different types of assets. It also may have the type of asset that's in it. Like manholes will have MH for a manhole. Not very creative, but you know, when you have flights on the airport, I don't know if they have identifier numbers that reference the runway or the taxiway that's located, you know, but it may, you know, so, but that might be something that, you know, could be utilized, so that if you see just the identifying number, you know approximately where it's located or what it's doing. When you're collecting the information about your assets for your inventory, one of the things that you want to do is keep in mind, and even though that this will be covered in greater detail, of what's the consequences of that asset failing. What does it do? When you're out there collecting information, what does that asset do? For a pump station, you know, it pumps sewage. So if it fails, it's not going to do that anymore. What would happen? So you're kind of looking at what kind of level do you want to maintain your assets at. And these are things that you collect at a basic level as you're out there looking at them. So you know eventually where to prioritize and focus your energy, because once the inventory is done, then you're going to start doing condition assessment, risk assessment, and that becomes much more time consuming. So as you do your inventory, you need to start thinking about where you're going to focus the next phase of your asset management program. So if it's something that has a health and safety issue, safety equipment or anything like that, is something that you want to prioritize your next phase of your asset management program. This is really an asset management sheet that is used, and I don't know how clear, but it's a lot of data on there. And this is information saying, okay, what type of asset ID? Is it area and grid? You know, which building is it in? Where is it located? So now, you know, it's a 01. So we're developing kind of a smart ID. So we know it's in the grid building, it might be on the first floor, so you now have another identifier. At the same time, you're collecting information about what you're having for your inventory. So you create your smart ID based on your criteria. So you may have location. So if you have location, building location, you can have no one. And then if it's on first floor, second floor, where it is, and so you have that as a second number. So when you see it, you know that that piece of equipment is on the first floor. And if there's multiple of the same equipment, you know, how are you categorizing? Doesn't say on this sheet, but a lot of sheets will say they'll be numbered going from south to north, 1, 2, and then from east to west. So those will give you, again, you have multiple of the same units. It gives you a system to start numbering how you're going to do it. You know, then it asks you, you want it in good condition. So you're trying to find out where you're going to focus as you go forward. What is its capacity? Is it under capacity, full capacity? Does it have excess capacity? So again, that helps you. And if it fails, is it safety, environmental, and then in this form, so you're going out there and you're asking these types of questions. Even if you don't have the answer, having it blank, eventually someone's going to look at that does have the answers and help complete the inventory. So even though you're doing the inventory, it doesn't need to be complete at the time that you're doing it. Okay. Where can we find data? A lot of times you can start off with the New Hampshire state will have an inventory of pretty much everything that they purchase. So they'll have an accounting record of inventory. So you can start from that inventory. If it's basically all of the vertical assets at your wastewater treatment plant, or, you know, so somebody in the finance department has a list, and it may be we only keep track of anything 5,000 and greater. So that means that at least you'll have a starting point for your data collection. Okay. If you're doing your GIS, you know, where can you start? You know, do you have information from the assessors, you know, from engineers and everything? The one I just did for up at north of Brentwood, everything was done by actually construction documents. You know, so we went through and we looked at all construction documents, and we would have actually multiple ones of the same area where the water and sewer was different from one plan to the other. And the only way we could figure out which one they built was looking at the aerial photographs, because one plan had these fancy curved houses and the other one had these square box houses, and they built the square box house. So that was the plan that we put the sewer in from that data into their GIS. And then that way, when we go out there to verify, we'll be able to look at it. If you're doing the vertical assets, the computerized maintenance system should have a list of all major pieces of equipment that you're maintaining. So that's the source for your inventory. Engineering specs for Seabrook. You know, they had no identification numbers, they had no records. Up in our Vermont office, Dave Wheeler asked them what they wanted to do for a numbering system, and basically they followed the specs. So all your equipment in the specs have identifying numbers, you know, what they are, pump equipment and everything. So they did their whole maintenance system based on the spec identifier numbers. So now they can look back at the history, what the spec was for the equipment, and then, you know, when it was purchased and so on and so forth. So, you know, you're looking at different things that come out and make it available. Sometimes the identifier numbers, when you start looking at different plans, old sewer systems become storm drains. So a lot of times you may have two identifying numbers or two ID numbers, one of the old plans and then one of the new systems. Okay. When you do a inventory, you have to think about who's going to be using that information, and you have to figure out what relationships are to everything. When I walk into a pump gallery, there's a lot of assets in there. But if those assets were just random throughout the whole facility, it would be difficult for me to visualize. So the way that we set up most inventories, we sit down with the client, is based on how the operators visualize. So we ask them, how do you want to set up your hierarchy? And so he says, well, when I walk into this building, the first thing I look at is what is in this particular room. So the hierarchy is creating that first container. The container is that room. And then you look and you break out your hierarchy by heating and ventilation system for that room. And then you break out the electrical in that room. And so you make it as visual as possible for the operators or for the clients as they walk into a room to understand when they go through your inventory, they can find what they're looking for. Because if it's all on a large table, it becomes unmanageable and not easy for your client to find things and locate things. So we go through that. A lot of software will allow you to have different types of hierarchy. So you're looking, you have each room, you go down to the second floor, and everything that's in that room, you have it all visualized. But now you ask the heating and ventilation guy that takes care of everything, how does he want to see it? He wants to see all the heating and ventilation on one table so he can see what pieces of equipment are similar, what he can take care of and what he needs to address. He's not so concerned that, where in the room. So you may create a second type of hierarchy where it's just heating systems or just electrical or control panels or just flow meters if someone comes in. So there's different ways of looking at your inventory, but what you do is you try and talk to the client on how he wants to see it and also how deep he wants to see it. Because you may have a generator and then attached to the generator is the fuel system that feeds it. And then if you want to break it down, you can break it down to the starter motor, the radiator. So all of a sudden, it goes from the treatment plant to the generator room to all these other levels. And typically they recommend you go down 7 levels of hierarchy to really be able to manage your assets and understand what's failing and what's not failing. So it's important to go through that process with a client on what you need. These are examples of containers. The operating room, the pump station. So these would be the things that he would look at and know in this container what's going to be in my inventory. So under buildings, you're looking at structures. Okay. We didn't rehearse. I didn't do that well. Okay. Heating system, plumbing, rolling stock, you're looking at vehicles, heavy equipment. So you're starting to break out what you're looking for under what container. And these are the structure. Again, you can have containers within a container. So again, you work with the client on how they want to manage their inventory and figure that out. Here is an example. Okay, we have the wastewater treatment plant, and then you have the biomass building, pump building, operation building. Under the operation building, you have the press room, second floor, bathroom, chemical storage, lunchroom, lab, rolling stock, maintenance, first floor, floor building, and then all of a sudden you hit your pump room. Then you're looking at actuator 1, actuator 2, And then see how it keeps on building down. So the reason for that is, again, to make it as visual for the operator, because most operators, they don't want to use search tools. They want to say, boom, I'm going to the operating room. Yeah. And eventually, they will also rename those. You know, they'll have names that they use in the facility to rename them. And they'll go through and they'll say, okay, I want things to be different names. So each one of these are different asset types, different data linked to it. This is the data that you're collecting, model number, serial number, you know, asset status, is it operating, is it abandoned, and you go through this table and you collected that information.
John, is there any shared shared assets between? Can you cross-link items from one hierarchy to
Yeah.
another?
Basically, it becomes a child asset of two locations. So say that you have and this happens a lot with portable pumps. A portable pump might be used by one department or another department, you know, and it's mobile. But it becomes a child asset of all of them. So they all see that asset in their inventory. And then if one does maintenance on it, all of them see what maintenance was done on that child asset. So yeah, there's a structure. So when it belongs to multiple companies or departments, you're able to set that up. Okay. When we look at horizontals, we're looking at, you know, roadways, sewers, pipes, runways, and yet it's becoming much more well, I should say that it's probably one of the fastest growing asset inventory fields out there. Most people feel that they have an inventory of their vertical assets. But what they don't really know is what is out there horizontal that's out. You know, what's in the ground? You know, how are roads positioned? You know, they're looking at trees. You know, how many trees are we maintaining? So all of a sudden now we're really kind of spreading out all over the place. Is that me? Okay. Okay. So, you know, how do you collect this information? Again, we've talked about, you know, using the plans, using what information you have readily available, then organizing your assets, putting values to it. A lot of times if you have horizontal assets, when we do bid specs and itemized bid specs, you're saying, you're putting values, that contractor is bidding on value of those assets. How many, you know, 12-inch valves, you know, how many vertical feet of sidewalk. So all of a sudden you're assigning values to it. And as you do the inventory, you've got to think about the same way that you're bidding packages, is that's how you want to collect your inventory. So you can put value and then put expected life in. Okay. I recognize that.
Alright, so my focus is really on the data collection, you know, out in the field type of thing. When I was collecting data in Rollinsford, I was, you know, looking for hydrants and gate valves, and when you kind of are really focused on that, you tend to notice things like this, and you say, wait, that's an asset to someone, but not the town, because it doesn't function, you know, as something that they maintain or part of their the vertical assets in this water system, basically, this focuses on the benzene removal system. That's in a container that's in the treatment building. So in order to collect this data, I used an iPhone, I used my camera, and I collected things like model numbers, serial numbers. With that, I could also collect condition. But in order to know basically what part of the process, whether it was a benzene removal system or another treatment process within that building, I had to use the whiteboard and basically write down what it is. So I took a picture of what it was first, overall, and then I took pictures of each data process within it. The horizontal assets, like John mentioned, they're hydrants, they're gate valves, and something like a water system. So the handheld Trimble GPS unit was used to collect this data, and it was used because of its accuracy. The Trimble allows sub-meter accuracy, which is 3.28 feet, as opposed to something like an iPad. iPads are very useful in data collection, but not if you don't know where your locations are and if you really want to focus in. The advantage to iPads is that they're easy for people in the field to use, like DBW workers. So if the points are already collected using the Trimble, then it can be modified easily.
Does the company own any Trimbles or?
We don't own Trimbles. That's actually a really good question. We actually, for this, I rented a Trimble handheld. It looks just like that. And I have all the grades, but, and I use that also. Yeah, it was just a local, they delivered it. It was very easy to get a hold of that. There is some software also that comes with it.
Jean, one thing to know is that we don't own one, but we rent them based on the requirements that are needed for the project. So that way, we're not paying for something that is over and above what we need for our client. So it's more of a gauging it for what our clients are looking for.
Nicole, is it like a weekly rental fee, monthly, magnitude?
Yeah, weekly and monthly,
Weekly,
daily.
monthly.
But yeah, it depends because some cities and towns already have all of this. They have a robust GIS system, so they don't need something like this. But Rollinsford really didn't know. They know where their hydrants are, but they don't know the actual locations and in space. So yeah.
How do you, who sets the accuracy requirements?
There aren't any accuracy requirements. It's really how, based on the town, how accurate do they want to be.
That's my point.
Yeah.
Does the town tell you, I want this within a yard or a meter or
We
6.2
can do-
inches?
Yeah, I mean, we can do whatever the town wants.
But they told you in this case how close they wanted you to fix the hydrants?
They didn't specifically say, but we're going to be using the GIS. I mean, basically, we wanted it to be as accurate as possible to help them so that they would know, because with gate valves, there could be some every 15 feet or something like that, or less. So if we have 15-foot accuracy, that's not really helping them a lot. So.
If you have a buried asset, you need to be about as specific as possible,
Yeah.
otherwise you're digging up the earth
Yeah,
to
that's
try and locate it.
basically the assumption that, but I think in the future, I think it's important to ask the client how accurate they want to be. And they may not know, but.
In the case of Rollinsford, they really didn't know. So we went through and said, this is what we probably need, up to 3. But we ended up giving them 2 different software. One that doesn't show the accuracy, but they're able to do their work orders and everything else. And then we gave them also the GIS, which gave them accuracy that they could do from the computer if they needed to go out and dig up from under a snowbank where a valve is. So we did give them both levels.
And,
Were you able to charge for that as part of the project?
yeah.
So we didn't pay just for the outlay, but just to do
But for us, how you just ballpark? For a big one. Something like that. Yeah. Okay, something like that, okay.
So, I think we're good.
Sorry.
No,
So,
questions are good. So the, like I said, the iPads are useful for collecting things like attribute information. But the Trimble handheld also can be, it just requires an extra step. So that leads us to data dictionaries. Basically, the real power of the GPS lies in the data dictionary. A lot of people don't understand them, they don't use them. It took some digging, but I get it. Basically, it's a database that works with GIS, and it works based on existing features and attributes. So if you already have your system in GIS, you can bring that to the GPS, basically update attributes, update locations if they need to be updated, and then it goes all the way. It's a database, so it's really powerful. Sometimes it can be overkill for a small project, but it's great for asset management for that. And I'll show you some examples. You can make custom data dictionaries for projects if they don't already have one. There's also data dictionaries available at state levels and federal levels that can be downloaded and transferred correctly. I'll show you some of those. This is an example of the data dictionary that I made that was custom to what I was doing. This is actually for Allenstown, New Hampshire, based on the stormwater system. So the features to the left are basically what I knew I had to collect. I linked those to the existing GIS, which we have a pretty good GIS for Allenstown. So I wanted to be able to use that existing information and just update it. And then the attributes are basically what I wanted to know about each thing, each feature. So for example, for the outfall, you can see it's lightly highlighted in here. So just focus on that. So for the outfall, for example, I plugged in, I want to know who it's collected by, but I want to have a drop down in the field. I don't want to sit here and start typing things in. So I pre-programmed it to my initials and the other person that I figured would be collecting data as well. And I just went along. I was able to collect real-time sampling data, which was really useful for this because basically for every outfall I have all this data and it goes straight into GIS, and I'll be able to show you how that works a little bit. So recently I was exposed to the VTrans. Their way of, they have a data dictionary as well, and VTrans is Vermont Highway Department. So they have this bridge or culvert inventory form, and this is something that you would pull up like in an iPad, and then I looked online and I found that this actually was available as a download to transfer directly to the GPS. So how it works is that the category, the everything in bold that's numbered becomes your feature. And then everything in blue is your attributes. So with this, there's no setup at all, and you're out there, you're just selecting drop downs, and that way the data is collected exactly how they want it, and you're not making anything custom. So I also did a quick search for the FAA, and it appears that they also have data dictionary available. And this is an example. This is just a list, but for airport facilities. And I would definitely dig a little further into that. And this is showing basically the CAD. So with Rollinsford, we started with CAD because we didn't have any GIS. So I wish I had a pointer.
Turn the switch on the side of the thing.
The switch is on
Is it?
in order
Okay.
to advance the slides.
Anyway, so that's what the water system looked like before before I went out and used the GPS. So I was able to transfer basically the layers from CAD to GIS to the GPS. And then along with the advantage of that is that all the attributes go with it. And once it's transferred to GIS, it becomes a data file rather than a layer. And layers are, they're basically dumb lines in CAD. But once they're transferred to GIS, they mean something, and you can use that in run calculations. So once that is transferred, the picture to the right is what the map will look like in a GPS. So it's pretty fuzzy, but and you can assign based on your custom data dictionary. You can assign colors and shapes. So it's not just in this example, it's just X's. But and then when you're out there, it'll show you moving along with the system. So it's pretty useful in that regard. This is just a window. This is the software you need to run the GPS, and this is how the data transfer happens. You'll note it says connecting. It's not connected in this example, but basically your shapefile will show up right here, or your features, and then you just hit transfer, and then all of a sudden your shapefiles are on your GPS unit, which is great. And now the next few slides are going to show you basically big picture, how does it all work? And this is the completed water system for the town of Rollinsford. And so the red dots show the hydrants in the system. The blue rectangles show the water shutoffs for each building. And the black and white circles are showing the gate valves in the system. And what this does for the town is basically it tells them where their assets are. And with having that information, they now know how many gate valves they have in the system. They know they can set a maintenance schedule. They can figure out, when do they want to exercise the valves, and a replacement schedule. So I want to highlight now. This is a data dictionary that I had set up. This is a custom one for Rollinsford. And so gate valves is highlighted as that's the feature. So going from that map. And so the attributes that I wanted to collect with the gate valves were date, time, ownership, collected by, etc. And then this is a screenshot from GIS. This is an attribute table. This is really the meat and potatoes. This is all your data. And so you can see, so if you kind of scroll your eyes to the left, you can see, if you read the columns, you see ownership, you see collected by, you see that's all filled in. And you see feature name, it's a gate valve. And so that's the link. So the data dictionary will populate your whole GIS database, and you have that data. So there's no recording or entering data in by hand. It's all done. So it's pretty awesome. And that's it. Questions and answers.
So I just thing that I wanted to mention, let me call. One of the things that Heidi talked about, how CAD has really dumb lines, and that's really not true anymore, thanks to John and Howie and everybody else. That one of the things that we go into the town and they have a good CAD or a good GIS of their system, we're now able to bring their system into our CAD with all the attributes. And then at the same time when we're done, we can do the drawings and everything else, including also these attributes, and then at the end be able to provide that back as a GIS to the client as with all the attribute information. And one of the things is because of that capability, we're really getting smarter and working better with these two systems.
And John's referring to AutoCAD Civil 3D, which is smart lines, but there still is the other AutoCAD, which I use also, and that is just
Not so
straight line.
smart.
And with Rollinsford, it was not the smart CAD, so
Right.
that's what I was referring to.
Yeah, I did want to mention that.
Does anyone have any questions?
I got one, what the heck is this first culvert?
Which culvert?
Yeah.
Basically, it's a culvert that, at the end, it's got this big hole from erosion.
Oh, so the end is it flush with the ground?
Right, yeah, you've got the ground and then you've got this dip and the fish is not right from us.
The perch.